solve word problems, we kind of have to understand what is happening. So everything in this section, the quadratic word problems, we have an x squared, which means it's a curve, it's a parabola shape. Now, many of them are facing down, some will be facing up, but the key thing is when we find the solution, it could be one of 4 different places. It could be the maximum or the minimum of the parabola where it changes direction. This is the highest or the lowest point. It could be an intercept. It could be here. In this case, a ball is shot into the air and lands over here. So the y-intercept is where they start. How high is the ball when it's shot? The vertex is how high the ball gets, and they may ask, at what time does the ball reach maximum height? And the third option is where it lands. This is the x-intercept. So it lands at 10 seconds or -2. But that doesn't really make sense. The parabola keeps going, but we don't usually consider negative answers. You can't go back in time. So the problem with word problems is we've got to figure out not only what the answer is, but we've got to figure out what they're asking for. Are they asking for the vertex or one of the intercepts? So to help us, we're going to focus on a key word. Anything with minimize, maximum, highest, lowest, any of those ultimate words where it's the biggest or the smallest, we're looking for the vertex. That gets easy. As soon as you see that word, you know you're looking for the vertex. The intercepts, notice that there's no maximum or minimum in any of these questions. At what time does the ball land on the ground? At what production level does the company make a profit? So the key thing here is if we don't see the word maximum, highest, lowest, we're going to find one of the intercepts, and we might need to figure out which one it is. Another thing about it is typically, and they may not say it right in the question, but the intercepts always have something is 0. So at what time does the ball land on the ground? Well, the height is 0. So we make the h 0 and we solve for the time. At what production level does the company make a profit? Well, we want to find where the profit is 0 and go from there. That's where it crosses the x-axis. So keep in mind, vertex always has minimum, maximum, or highest. Intercepts don't have that. Something is equal to 0. So let's practice this. We've got some examples here, and we have to read through this and find out, is it the vertex or is it an intercept problem? So find the maximum profit that a hotel can make each night. As soon as you see maximum, vertex. Read through the question, desired radius to maximize, vertex. So again, we're just looking for that highest, lowest, or maximum, minimum. At what time does the rocket land on the ground? Well, it lands on the ground, height is 0. There's no maximum, minimum. So this will be an intercept problem. What is the maximum height? Vertex. How high is the diving board? Now they are asking high, but it's not the highest or the lowest. It's just the height. So this is where we start. It's an intercept. It's kind of like the platform in the picture. How high is the platform? And then we throw the ball from there. What is the maximum area possible? Maximum vertex. So this one's easy once you get used to it. Maximum, minimum, it's a vertex problem. So the next one is deciding if it's an x-coordinate or a y-coordinate. Now the key thing is you'll notice that we don't have x's or y's in this problem. We have h and t. So we're going to find the maximum height. We're trying to find height which starts with letter h. And if I look at my two options, h and t, I'm finding the y-coordinate. This one here, find the ideal number of units, n. I look at n is in the x-coordinate spot. I will find the x. Find the time is the x-coordinate. Find the maximum number of fish. Fish starts with f. F is here, y-coordinate. And these are just made up words, but just to show that you don't even need to know what the object is. We're finding the Regenreuters. We're looking for an R. The R is in the x-coordinate spot. Right there. So, the biggest problem is finding out if it's vertex or an intercept. And then once we have that, we need to know if it's an x or y coordinate that we're finding. So now that we've got that, let's try the first example. A rocket is launched from a platform into the air. So let's draw a little platform. Its height above the ground given by the function h. So h is going up in the air, and it's going to be shot into the air and down. H is in meters, time is in seconds. So the first question is find the maximum height. Maximum is vertex, and height is the y-coordinate. So we're going to find the y-coordinate of the vertex. The vertex is 13, 140, and we want the y-coordinate 140. The only thing we need to add now is this is height. Height's in meters. I need units on my answer. Next one, find the time when the rocket reaches maximum height. So we still want vertex, but now we want the x-coordinate for the t. So this time it's 13. If we look at the question, seconds, 13 seconds. Now this one, at what time does the rocket hit the ground? We have no maximum, no highest, no lowest. This is the intercept, the x-intercept. Now, the key thing here is, if it's in vertex form, we're going to complete the square. So I've transferred it to another piece of paper. I'm going to do it here so I have enough room and so I don't squish it in. Now, vertex form, we always want to complete the square when we're doing these kind of problems. So I need to move these numbers over, and specifically I'm going to move this one first and then that one. Basically I'm doing algebra. Start with the adding, subtracting, then the dividing, multiplying. So this becomes 0, and I've moved the 140 over. I'm subtracting 140 to move it, so negative 140 there. Divide by negative 0.8. Now that I've got the perfect square, there's nothing on the outside of the brackets. I'm going to square root both sides. And I should always check that I can't simplify. In this case, 25 goes into 175. 25 times 7. The 25 is a perfect square. And so I took the 13 and I added 13 to both sides. Don't forget the plus minus. The square root of 25 is 5. And then I'm done. As this is a word problem, I'm not going to leave it like this. I need to plug it into my calculator and solve for a decimal answer. So I'm going to do 2. I'm going to start with 13 plus 5 root 7. And if I do 13 minus 5 root 7, I get a negative answer. So I'm going to ignore the negative answer. We want the positive. At what time does the rocket hit the ground? 26.2 seconds. So we don't do the negative because we're not going backwards in time. The rocket is not falling behind the platform. And find the height of the platform. So the platform is where we shot it from, shot it up in the air. So this is the height at time equals 0. That is the y-intercept. So I'm going to plug in 0 for t. And again, this is the height, so it's 4.8 meters. All of these have units. Anything with time would be seconds, which they tell us in the question. Anything with height will be meters. They tell it in the question. So check your answers. So this one I want to show because it's in general form. And what you'll find is the ones in general form just take a little bit more work. Now, for this, if we want to find the vertex, remember, we always start with negative b over 2a. Once we have the x, then we plug it in and find the y, or in this case, the n and the c. Now, a shoe manufacturer can reduce costs by producing more units until resources become scarce. So if we have a big factory, it's probably pretty expensive to begin with. Once we start producing more and more units, the average cost will start coming down, which makes sense. The more you produce, the cheaper it gets to produce it. But you reach a certain point where costs just kind of flatten out. And if you keep going, it gets hard. It's hard to find enough employees who are good at this. Maybe you have to do more training. Maybe you have to pay more overtime. And so costs start going back up, and it forms a parabola. So in this case, we want to find out how do we get the lowest or the minimum average cost? What is the vertex of the problem? So in this case, what is the minimum cost of production? We need to find the vertex. So using this, so the x-coordinate is 107.1. The y or the c-coordinate, the cost, I'm going to plug in 107 into this. So after plugging in the numbers, I get 46.43. Round to 2 decimal places. This is for money, cost of production, so 2. So what is the minimum cost of production? This is the y-coordinate. This is the 46.43. And the units are dollars. What is the number of units to minimize costs? Well, this is also the vertex, but it's the x-coordinate or the n-coordinate. So it's 107.1, and n is number of units in thousands. So it's not 107.1, it's 107,100 units. So always go back and check the units for the question. And the third one is, what is the x-intercepts? So remember, when we have general form, we're going to use the quadratic formula for all x-intercept questions. Find the solutions. We're going to make this 0, and then we're going to plug in a, b, and c into the quadratic formula. So negative b, it's already negative, so it's going to be positive 15. Negative 15 squared minus 4, and c. All divided by 2 times a. So I'm going to start with the radical, plug this in. And I'm going to stop there. And I'm going to stop because it's a negative answer. So no solutions. So what's happening with this question is we have costs. They start out really high when we start our factory. They get lower and lower as we produce. They reach a certain point, and then they go back up. They never cross the x-intercept. And the reason why is you can never have negative costs. You never get so cheap that you're getting money back for producing. So what does it mean that there's no solutions? It means that we never reach 0 costs. No matter how much we produce, we always have to spend something.